Alright, so as you can see, this is a huge table and it contains approximately 98,252 values. Needless to say, it's a huge table. So what we're going to do today is we're going to load this table, that is this Excel sheet, into a Jupyter notebook, and then we're going to run a set of codes to get some desired outputs. So I have already loaded this into a Jupyter notebook and I have already performed some functions, and I'll just go through the functions and the output once again. As you can see, the first block of code reads import numpy as npm, import pandas as pd, and import os. Here, numpy is short for numerical Python. It supports a large multidimensional arrays and matrices, along with a large collection of mathematical functions that are used to operate on these arrays. Pandas is a manipulation tool built on the NumPy package, and its key structure is called data frame. Data frame allows us to store data in the forms of rows and columns. The import OS here, the OS module is a part of the standard library within Python 3. OS module provides function for interacting with the operating system. Alright, so we'll just run that piece of code quick. I just run this code and you can see it's running, and run this code. Here df equal to pd dot read underscore csv, and this means this is a location of my Excel sheet, and I load the Excel sheet into this and I just show the output of the Excel sheet. So it will show me something like this. So this is my table, and here I have five values, last five values. As you can see, it contains whole values 98,252, and it has approximately 98,252 rows and 8 columns. The next one is df.head. This returns the first 5 rows of the data frame. So when we run this, we see the first 10 rows of the data frame. It returns the first 10 rows. As you can see, it's here, it's the first 10 rows, and you can see it's all the same as these. df.tail is the same as df.head. It returns the last 5 values of the table. df.sample returns a random set of 20 data. Okay, so df.sample is never that reliable. It just gives us a sample that is from here and there. So if I run it again, I'll get another set of random values. Here you go. df.shape. df.shape is a shape attribute of pandas. It stores the number of rows and columns. As you can see, there are 98,252 rows and 8 columns. df.info. df.info shows us the data type of the attributes in the column. Serial number is an int type, observation date is an object, province is an object, confirmed deaths and recovered are float types. Alright, here we run this piece of code. This piece of code will convert the observation date and last update date to date time. Here we convert them to date time. Since they are currently taken as object, we convert this object data type into date time data type. Here pd.to underscore date time helps convert the string date into Python date time object. Alright, and then the counts confirmed, deaths, and recovered will be converted into the int type. Here it's float, and we convert them into int using these pieces of code. And I'll just run it quickly. Alright, so the next one, I just run some pieces of code and then I do this. Let me just run it. Here, what this does is since the final count of the cases are present on 29th August 2020, we will create a separate data frame for the same. Here we have created a separate data frame. Now it has only 748 rows and 8 columns. This df underscore update dot is null dot sum. We find out how many null values are present in each column. You can see that province or state has the largest number of null values, that is about 168. Alright. out of now we can see that out of 998,252 records, we are only now left with 742 records, and most of them don't have a province defined since most of them are null. So what we do here is whenever a province is null, we replace it with a country name. So I'll just quickly run these codes. It's running. The star here shows that it's running. Both of them are running. We'll just give it a little time. Okay. What we do next is we now perform encoding of country to country ID and province to province ID. Alright, here province is changed to province ID, country is changed to country ID, and then we run this piece of code. Alright, so we can see that province and province country ID is added here. Next, we construct a heat map. Okay, so heat map shows us the correlation between various variables, and we can see that there is no correlation, there is no strong correlation between the variables except for confirmed and dead variables, that is 0.78. 0.78 is closely followed by 0.69, that is serial number and province ID. Okay, that's that. And we run this piece of code. This shows us how many countries have been affected by COVID-19, and it's huge. You can see that the total number of countries impacted by COVID-19 till date is 223. Alright, so this value may not be accurate since there might be a lot of countries that are affected by COVID-19 after this data is released. Then next we represent confirmed cases per country. We run this code. This will construct a pie chart to represent the confirmed cases per country. Here it is. We can see that almost half of it is divided into three countries. You can see that US leads with 23.85% of confirmed cases all around the world. It makes up about 1/4 of the total confirmed cases in the whole world. The numbers in Brazil have slightly increased drastically, placing them in the second spot. As you can see, India has moved to the third spot with respect to number of confirmed cases, taking over Russia. Russia is followed by Peru, South Africa, Colombia, and so on. Here's a lot of different countries, and it's not visible. Next, we run this piece of code. Here, we see that among the top 5 countries with maximum confirmed cases, Russia is doing better. Here we can see that USA has the most number of confirmed cases as well as deaths, followed by Brazil, India. This is just a classic representation of this table. On the next piece of code, it will show the country that has the lowest number of death rates. Have confirmed confirmed cases. Among the top 5 countries with maximum confirmed cases, Russia is doing better than India if you consider both recovery rate and death rates. Okay, so this one will show a bar plot. Okay, so this shows the ratio of the confirmed cases, record cases, and deaths. Blue is the confirmed cases, green is the record cases, and red are the deaths. The next piece of code. Since China was the first epicenter, we will now check for provinces within China. We'll just run these pieces of code right here. This will help us to find which place in China has the highest number of death confirmed cases, and we can see the Hubei province in China is leading with the highest number of confirmed cases, while the least is in Tibet. It's almost invisible. Okay, so we run this next piece of code. This is the per day statistics of China, where the line graph shows the flattening of curve for confirmed cases. It's confirmed cases, it's flattening here. On April 17, there's a huge sudden increase in death and confirmed rates. As you can see, there's a sharp bump here, and it's probably on April 17th. A next piece of code, and from this next piece of code, we find we just print out what was here, the confirmed, recovered, and death rates, and next we just show a bar plot. And from this confirmed cases plot, we can see that the number of new cases have been declining over time. It's suddenly increased around here, that is 17th April, which shows a sudden increase in the number of confirmed cases. And it's periodically decreasing over time. Now, we perform the same death case increase, and now it will show another bar plot. The number of death rates have reduced to a great level, but on 17th April, there are about 1,290 deaths reported in a single day. This blue line stands for 17th April and has about 1,290 deaths in a single day. China has reported this increase as some miscalculation on their end during the initial testing phase of COVID-19. Of course, we have no way of knowing if this is true or not. Let's run this code. And similar to what we have done here, per day statistics for China, this is a per day statistics for Dubai. And it shows the confirmed, recovered, and death cases. As we can see, there's a slight increase here. That's on April 17th. Now we go on to the world, excluding China, as we have seen China above. All right, so let me just run this piece of code here. Okay, the global cases are on an exponential increase, and the death rates do show some divergence, which is a good indication. Okay, so this is the per day statistics of the world, and we'll just run some pieces of code here, finding which day has the highest number of confirmed cases. 29th of July saw the highest increase of confirmed cases with 3.37 lakhs in a single day. That's a lot. Just we'll just run these two pieces of code right here, and we'll be done with the world. Okay, so this is the confirmed cases increase and also the death case increase. Both of them have increased exponentially. Global cases have been on an increasing trend so far. 29th July saw the highest increase in confirmed cases with 3.37 lakhs a day, just as I said earlier. Coming to death rates have also increased globally. 29th of April has the greatest number of deaths in a single day. That spans to about 10,485 deaths in a single day. The whole world. Okay, so we move to the next epicenter after China, that is Italy. Italy was the second epicenter for COVID-19, hence we look at these numbers. Italy has had more than about 1 lakh confirmed cases on a single given day. Alright, so we run this code. This is a per day statistics for Italy, as we have seen for China and the rest of the world. We'll just run this, and this shows the last 5 values of the table from Italy. I'll run this piece of code and I'll explain what it means. Okay, so this is the confirmed case increase, and this is a death case increase. It's just as I told you before. And the highest confirmed cases and death case increase was reported on 30th March. Highest number of deaths in Italy was seen on 27th March with 919 deaths reported. Of course, the real values may be less or more than this, as not all of the people who have contracted COVID-19 go to a hospital care, and not all of them get diagnosed. So we move to the next epicenter, that is the US, and this is the per day statistics graph for US. US um, still has no flattening curve and is still leading in the number of cases in the world. The number of cases in the world are largest in US, as we saw earlier. It's about 23.85% of the total confirmed cases. We'll just run this piece of code right here. All right, so this shows us the last five rows of the current table from US. And we'll just run these two pieces of code and it will show us the confirmed cases increase and the death cases increase. Okay, so similar increase has also been seen in deaths and confirmed cases. 16th July has recorded the highest number of confirmed cases. That's about 78K in a day. That's a lot. That's the reason why USA is has the most number of confirmed cases and death cases in the world. Compared to death rates, death rates has also seen a similar increase with the highest number of deaths reported on 16th of July. All right, coming to India, the confirmed cases, as we know, are just going on increasing every day in India. So there is a need to get a flatter curve for confirmed cases. So we find the number of confirmed cases in India in a single day. We run this piece of code right here, and we can see that this shows us the last 10 values of the table in India, and this will show us a confirmed case increase. This will show us a death case increase. Here we go. 21st of August shows the highest number of confirmed cases. That's about 69,239. The peaks have also been increasing almost every single day. Coming to the death rate increase, highest number of deaths in a single day is 1,986 for India as of 16th June. Next, we perform just some simple calculations. We find the mean and standard deviation of cumulative cases. This will just help us understand how the standard deviation goes, and this is a bar plot uh, or a histogram to show the confirmed cases, and we'll run this mean and standard deviation for China, Italy, USA, and India. Same a histogram, and here we see the mean and standard deviation of deaths, histogram of deaths, and the distribution of confirmed cases. This is not important. This is just a distribution table. So that's it. These are some of the pieces of code I have run. So if you have any doubts, just watch the video again. And thank you for watching this video so far.